This is a male coupling for the QHY Polemaster, and I've measured this across here with a micrometer, and it came out to 36.5, and the pitch is 1.25. So I CAD modelled this up as a female part, thread milled, and we're going to do a test print to make just a little sort of 6mm extrusion to see whether this screws into it or not. And it's printing now. I got my new 1 kilo spool of PLA, and so we'll hopefully, after this is done, we'll be able to hopefully screw this in, and if it works, well then we'll move on and design the bracket. Cool, back soon. You can see the threads. Just doesn't help that it's black on black. Using a 30% fill in a crosshatch pattern. We're at 71% completion. So, and I've run the feed rate. I'm override it's actually the feed rate's at 150%. So hopefully that bloody screws onto this, and if it does, well then we'll be able to design a nice little bracket. But yeah, this is great. Cool Magoo. This nut is too tight. It doesn't quite fit, so I'm reprinting it, and I've scaled it up in the slicer by a small factor, and we're going to try that. Trial and error. I think it either shrinks a little, or it prints a little undersized, or I've measured it wrong. But I think I've measured it correct. I think it's just the plastic, as it cools down, it's not necessarily dimensionally accurate. So we will experiment with it. The threads turned out pretty good. They just too tight. So yeah, hopefully we'll get there eventually. Back later. The second one worked. I couldn't have asked for a better print. It just absolutely screwed straight onto it. Now, on the Creality Slice program, there's a scale option, right? So it has X, Y, and Z set to 1, 1, and 1, right? Now, to increase our first attempt, which didn't fit, I took a guess and did 1.03 on all three. And so instead of being a 60 by 60 square, it was like, I don't know, 61 or something. So, and that is the scale factor. So from 1 to 1.03 on all of them. And it worked great. So now that we know what that needs to be, we can go and design the bracket for the actual final part. But yeah, that's just wonderful. Thanks for watching.
Okay, so this is the part that we just machined or printed, and it was undersized, but we scaled it up in the Creality Slicer program. So I'm not going to change the CAD model dimensions of the hole. However, I will scale it in the Creality Slicer. Now, what we need to do is just take a look at this information. The thread information is major diameter 36.5 millimeters, minor diameter is 35.25 millimeters, and the pitch of the thread is 1.25 millimeter pitch, and the length of the thread is 6 millimeters through the thickness of the part. Now let's go and create a new part, because we're going to design the actual bracket now. And we'll call it final part, final bracket we'll call it. And let's do a sketch on the XY plane, and we'll draw a line. Let's just take a look at this one again. Rapid dimension. Just bear with me a sec. Let me just do, let's take a look at that sketch. So 50 millimeters. Yeah, alright. So let's draw a line. Let's draw a line 50 millimeters. Now, obviously, when we scale it up, it's going to be a little bit bigger, but I'm okay with that. It's not that important. It's, like I said, 50 this way. Let's try that again. 50. And let's just trim off this and this, and let's draw a line from the diagonal to the other diagonal. Let's draw a circle, and 35.25, which is our minor diameter. Let's trim these lines, finish the sketch. Now we need to extrude in the positive direction, otherwise it'll corrupt the STL. So let's extrude it +6 and hit OK. Now let's sketch on this face. Let's draw a line from the origin .50 millimeters to there, oops, and then 6, and then to there, and then we'll just trim off these 2 lines. Hit finish, and then let's extrude that guy -50, and I'll do a union. Okay, and the other thing I'm going to do is sketch on this plane, and I'm going to put in some gussets. So let's draw a line from the end point to that end point, from there to here, start point, and then from there back to here, and hit finish sketch. Let's turn that around, extrude that guy. -6, and we'll unite, and then we'll do a sketch on this plane and hit OK, and do the same line from the end point to there, from there back to here, and from here back to here. Finish the sketch, extrude that one 6mm, and unite. Now we'll go to show hide, and we'll hide all of our sketches. Now on this face I need to thread it, so let's go into home, more, thread, and we're going to do a detailed thread. We're going to select the wall, and we're going to select our major diameter, which is 36.5, and our pitch is 1.25, and that's now threaded. So let's just double check that. Feature dialog. 36.5 is our major, 35.25 is the minor diameter, 1.25 and a 60-degree angle on the threads. So that's done. The only other thing we need to do is drill a hole in the base. So let's do that. Sketch on that plane. Let's try and get it in the middle this time. Draw a diagonal line. Okay, from the origin to there, and then from here let's pick the midpoint. Actually, let's draw a second line so we don't miss it, and then draw our circle, and that's going to be, what's it going to be? If it's a quarter 20, quarter of an inch is 6.25. I need to check my tapping chart to make sure that hole diameter, but I'll I mean, if we made it 4mm, it'd probably be alright. We just drill it out anyway. Let's do that and hit trim. We'll just trim up these lines. Hit finish sketch. And then extrude that guy. Extrude. Subtract. So there's the hole. Let's just hide the sketch geometry. And now that's the finished part. Let's export that as an STL. So we go File, Export, STL, and then go to the desktop, final bracket.stl, and I'm leaving the defaults. Select the part and hit OK. Then we'll copy that to the memory card, bring it into the slicer, and we'll scale it up by that 1.03 factor, and then we'll go and print it. Back soon. Thanks for watching. Okay, we're at the other computer, and let's open up Creality Slicer. Let's open up our CAD model. Final bracket STL. And let's turn this around, and this button here scales it. So instead of being 1:1, we're going to do 1.03, and on expert settings we'll change the fill density to 50%. Okay, so that's good, and we've scaled it up so that our thread will work. Let's do a toolpath to SD card. Actually, let's delete that. Let's delete that G code. Let's change this layer height to 0.2. And our feed rate, let's change that to 80 millimeters. Let's change it to 100 millimeters a second. Actually, let's back off this fill density to 40. It becomes a 3-hour print. Okay, toolpath to SD. So let's take this to the printer and print it. Back soon.
We have a successful bracket. So that's finished. Tomorrow we'll mount it on the Takahashi, and yeah, turned out beautiful. So I'm very happy with this printer. It just works. I'm also quite impressed with the JCar PLA. It just does a wonderful job. So, you know, beautiful surface finish, nice and smooth. So yeah, I'm going to bed. I've had about enough, so we'll be back tomorrow, and yeah, see you then. So that's done. I've got a lock nut on here so that it like a jam nut. this can go on the scope now. This is finished, so yeah, very happy with the way it all turned out. And we'll probably connect this up to a Raspberry Pi, which is this guy, and have like that as the computer to drive this, and that Raspberry Pi will do other things. It'll probably run the focuser for the Takahashi, because the ASI Air can only run one focuser at a time, and I need two focusers, one for the guide scope and one for the main scope. So we use the Pi to focus the Takahashi, we'll use it to control the Polemaster, and also maybe use it to control some security cameras in the observatory. I'm going to set up some wireless cameras to film when the scope slews and moves, so that it, if I'm remote, I can keep an eye on it, make sure it doesn't get tangled or wants to crash or something. So yeah, we'll go out to the observatory in a minute. We'll mount this, and yeah, thanks for watching. So I've finished mounting this Polemaster up on the Takahashi here. This is the 3D bracket we printed, and it's mounted on this Altazimuth mount, so you can adjust it. I just have to loosen that knob. I made this thing years ago on the CNC, so you can actually tilt it in two directions. So that'll be, I hopefully be able to use that as a digital Finderscope to find objects in the scopes here remotely without using this thing. So that's the Takahashi one, but yeah, this be a digital one. So, yeah, that turned out nicely. So yeah, cool.